Okay, what? Whenever you want. Here we go. So please open to problem number 3. Problem number 3. So problem number 3 in your homework. That is a problem that I was hoping everybody could do on their own, but I understand that that's easier to just say and hope for than it is to actually happen. So I was thinking about over the weekend, what do I want to do with calc? What do I want to do with calc? What do I want to do with calc? And what I'd like to do is I would like to look at problem 3 with you together. I'd like you to give number 4 a shot on your own in class. And I'd also like to look at number 8. Let's see where you can get with this. A box with a square base and an open top must have a volume of 3,200 centimeters cubed. Find the dimensions of the box that minimize the amount of material used. In order for this, sure. In order for this to make sense at all, you got to get started with it. See if you can start by coming up with the drawing for this situation. Just try to come up with a drawing, okay? Start there. Take about 40 seconds, try to come up with the drawing. Go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There we go. All right, let's see what you got. You should have a box. Looks something like this. All good there? Okay, and then maybe you try to put some labels on it. If it has a square base, what did you label the base? I like your idea. Let's go X and X. Does it tell us the height? No, there's no height, so I'm just going to write height. It's not the same because it's a box that has a square base. Doesn't mean that the height is the same as the base. Okay, yep, not necessarily a cube. Okay, so now what I would like you to do is take 20 seconds. See if you can write an expression for volume. Go. 5, 4, 3, 2, 1. Good. I heard some people say it should have 32,000 is equal to x squared h. That's your formula for volume. That's not what's driving the problem. What is the thing that's driving the problem? Minimize the amount of material. Would you agree that we want largest volume, but we don't want to use much material? That's the goal. And so I need an expression for the amount of material, which is a fancy way of saying the surface area that would be used in order to accomplish that box. See if you can come up with that. Take a minute, minute and a half. See if you can come up with that formula. Go. 5, 4, 3, 2, 1. Okay. Now, here's the challenging part. Let's just be frank and honest with ourselves. Top 20 people, they can be honest with themselves, right? If you couldn't do surface area and geometry, it's going to kind of suck right now, right? And that's just life as it goes. So I'm sorry if geometry didn't go well there. Fact is that that's something we need to know how to do. So what's the area of the bottom? X squared. Is there a top? There's no top. What is the area of one of the sides? And how many sides are there? So plus 4xh. Okay, so notice what I've got here. Okay, this is different than the other ones, but you notice that I have two equations. They both have x and they both have h. So what I want to do is I want to take this guy and be able to either solve for x equals or h equals and plug it in. What's it going to be easier to do? Solve x equals or h equals? H. So I've got h equals what? 32,000 divided by x squared. So that thing goes in for h. So you can see the second box is the most important. That's where the magic happens. So I'm going to go into this box here, and I now write the amount of material is equal to x squared plus 4x times 32,000 over x squared. I don't want to write it like that because I want to be able to take the derivative. I want to write it like a polynomial. So therefore, the amount of material is equal to x squared plus what's going to be on top? 128,000 over x. So if you just write the 4x over 1, you can see that you're going to have 1x in the top, an x squared in the bottom, so that's going to create an x in the denominator. You have 4 times 32,000, 128,000, okay? So what I've learned is that if you maximize something, this is kind of reviewed from the other day, if you maximize or minimize, the maximum or the minimum happen when the what is equal to what? Derivative is equal to 0. So remember, maximums and minimums happen. Whoop, that's really bad. Maximums and minimums happen when the derivative is equal to 0. So let's find this derivative. M prime is equal to what? 2x. This. Yep. Because that's 128,000 times x to the negative 1. We take that derivative, that's what we get. That's easy. Let's solve that by setting it equal to 0. 0 equals 2x minus 128,000 over x squared. I'm going to choose to combine that into one fraction. If I want one fraction, what do I have to do? Multiply by x squared, thank you. Top and bottom by x squared. So therefore, I get 0 is equal to what's in the top? 2x cubed minus 128,000 over x squared. So that's the derivative. Where's the derivative undefined?
0.
At 0. And that makes sense if we think about it here. You can't have a 0 height. You would then have 0 volume, right? That doesn't work. And then in this situation, and notice it says you can't have 0 volume. That's why it's an undefined piece. It makes the problem not work at all. But in this situation, I got to solve the top equal to 0. Solving the top equal to 0 isn't that bad, is it? Let's try it. 2x cubed minus 128,000 is equal to 0. What are we going to do? Yep, so 2x cubed is equal to 128 grand. It's like my bank account. I'd say it's like Minnesota's surplus budget, but that's actually 17.4 billion. Thank you. I want my money now. What do I do to both sides? Cube root. And I get x is equal to 40. Did we answer the question? The question says what?
Find the minimum amount of material.
No, it says find the dimensions. It says find the dimensions. So I know that it is 40 by 40 by, how would I figure out h? Plug it in right here. It says 32,000 divided by 40 squared. Anybody got that on their handy dandy calculator? Is it 20? Okay, the question is where we came up with 40. Do you mean this 40? So here's what I do, Bree. I see x is 40, then I go back to my picture. I say, oh, so x is 40, need h, plug it in there, I get 20. Not too bad? Is it 20? Did somebody plug it in? Is it 20? Okay, thank you. Okay. Where? Wherever you feel like it. Flip it over. Problem number 4. What I would like you to do now is I want you to try problem 4. I want you to try to set up the first 2 boxes, actually the first 3 boxes on your own. See if you can actually come up with an equation. It is slightly different, very similar to the last one, but just slightly different. Go ahead, take some time, do your best. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and pause. Okay. We'll see how many were able to take it the rest of the way here. Shh. So that's my shape. First of all, did you get x by h? If you put w, w, h, that's fine too. But the point is that these bottom have to be the same. Somehow it has to come across your brain that if it's a square base, you got to think to put the same variable there. Okay? All right? Now, I want to find the largest possible volume. Volume is x squared h. That's what's driving the problem. I should see that written down. What's different about the last problem is you're given the volume, weren't you? Yeah. You're not given the volume here. You're given what? The amount of material. Well, the amount of materials could be the area of the bottom, which is x squared, plus then the area of each of the sides, 4xh. So, very, very similar to the last problem we did, right? The difference is that this is what's driving the problem. So you're going to have to solve for h here and plug it in there. So how would I solve for h? What would I do first? Yes. Correct. 1200 minus x squared is equal to 4xh. What do I do with the 1200 minus x squared now? I divide by 4x. So now I can plug that in. The volume is equal to x squared times 1200 minus x squared over 4x. There you have it. What's going to happen with the x on the bottom? Cancels, and you get volume is equal to, on the top, you have 1200 then x minus x cubed over 4. Because one of the x's is gone. Now go ahead. So the x on the bottom will cancel with one of the x's there. So you just have one x distributed through the top. Now I could write this as volume is equal to, here's a little trick, I'm going to divide them both by 4. What's 1200x divided by 4? 300x minus 1/4 x cubed. Cool. Do you know how to take the derivative of that? Yeah. That's easy to take the derivative of, isn't it? I get 0 is equal to, what's the derivative of 300x? 300 minus 3/4 x squared. Okay? Look at the shape of the volume. What does volume look like? Goes like that, right? So how many spots are there where the derivative is equal to 0? Do you want the first one or the second one? Well, the second one is because we're trying to maximize the volume, right? That's the goal of the problem. Is that what it tells us? It says largest possible volume of the box. That's what we want. Okay? So let's try to find that. We took the derivative, set equals 0. How do I solve this? Add the 3/4 x squared over the other side is equal to 300. Divide by 3/4. So we get x squared is equal to 400. Square root, and you get positive and negative 20. Notice how negative 20 is going to give you that one, and positive 20 gives you the top one. So do we want the negative 20 or the positive 20? We want the positive 20, okay? So we've discovered that in this problem, x is equal to 20. So look back at the original problem. It says, find the largest possible volume. Have we figured out the volume by finding x is 20? No. So how would you actually calculate the volume then? Plug it in where? Yeah, you've got a volume function right there, don't you? Sitting right there. You can, but this one has an h in it. I've got x. I like that guy. Get my point? Yeah. So therefore, volume is equal to, what's 1200 times 20? 24,000? minus, what's 20 cubed? That's 20 squared. 8,000. Divided by 4. 24,000 minus 8,000 is 16,000. Divide by 4. 4,000. Yep. What? Oh, you sure can. Hey, last one we try today. Okay, I told you if you want to, you can give problem number 8 a look. We're going to look at it today. It should say a cylinder can is being constructed using a piece of aluminum. The can has a bottom, sides, but no top. 100 square centimeters is available for use of the can. Now, I want you guys to think about this hard, okay? Aluminum can. Steve, you could come up with the picture and see if you could come with volume. Go. Try that. Okay, let's see what you got. You should have a circle on the bottom, circle on the top, and you should have a shape like that. Has height and it has a radius. Of course, you remember because you love your geometry experience, what is the formula for volume of a cylinder?
Pi r squared.
Good. Pi r squared h. So that's what's driving the problem because it says it wants to maximize the volume. But I'm giving it another piece of information. 100 square centimeters.
Well, that's because we didn't code it.
It said it has a bottom. It says it does not have a top. What's the area of the bottom? Pi r squared. Ooh, this is the tough one. What's the area of the label that you wrap around a can?
It's height. It's the high something.
Good. If you take the label on a can and you unravel it, what shape does it make? Makes a rectangle. And what is going to be this dimension of the rectangle? The height. And then this length is the same as the distance around the circle, which is, and circumference is 2 pi r, right? So therefore, we got pi r squared plus 2 pi r h. Yep, lots of letters in this, right? Lots of variables, symbols. Which variable do we solve for? H. So I have 100
Why do we solve?
Yes, Maddie's 100% correct. She looks at it, she says, if you're going to solve for R, you got multiple R's. There's just one H sitting right there. Solve for the H. That's the easier option. The pi r squared here, that's the volume of the, or that's the area of the bottom piece. Okay? Now what are you going to do?
Divide by 2 pi r.
I divide by 2 pi r. So I'm going to plug it in. I get volume is equal to pi r squared times 100 minus pi r squared over 2 pi r. That doesn't look very pretty, does it? I'd like to simplify that. So volume is equal to, what's going to happen to pi? Everybody see pi will cancel? What's going to happen to one of the r's? One of the r's will cancel. So let's distribute the r through the top. What are you going to be distribute the r through the top?
100 r pi r cubed.
Over what's in the bottom? 2. So I get volume is equal to, let's divide each by 2, and I get
50 r.
50r, 1/2 pi r cubed. There's our formula. Have we done any calculus? No. None. This has nothing to do with calculus. This has to do with modeling problems, algebra, geometry, setting it up. Now we do the calculus. What's the derivative of 50r? Yeah, 50. You're like, well, calculus is way easy compared to algebra and geometry. Yeah, sometimes it is. What's the derivative of that? Yep. Got to solve that, right? So I'll add the 3 pi over 2, r squared to both sides, equal to 50. Now what? Amount of confusion. Good. Yeah, I'm gonna take 50 and I'm gonna multiply by the reciprocal. What's the reciprocal of 3 pi over 2? 2 divided by 3 pi. And I'll multiply that by that reciprocal. I get 10.61. Now what? Square root both sides. And I get r is equal to 3.257. So the question was, what radius and height should be used to maximize the volume? I figured out the radius. How do I figure out the height? Yeah, the height was this guy right here, wasn't it? So I'll try that. Parentheses, 100 minus pi times 3.257 squared divided by parentheses 2 pi times 3.257, and I get, looks the same, doesn't it? 3.258. That's the height. What's the last question? Volume is right here, isn't it? So I could take 3.257 and plug it in for that. I think if we didn't round, they would be identical. There you have it. Okay, I didn't want to move on to new stuff because I want to make sure we saw that piece. We're going to spend one more day on optimization, but it is possible. It is possible that we have a snow day tomorrow. If we have a snow day tomorrow, your assignment is to give number 5 a look. Okay. Yep.